inside? Now there's a lot of calculus students that have gone through and done the chain rule and written in different ways, but this is probably the most common layman's way of doing it. Well, that's why I got what's inside. I've got that in quotation marks because if you go on YouTube, it's not just Hubert that says what's inside. There's a lot of former students that turned into teachers that say what's inside. What's inside is this guy right here. Okay? So, the chain rule in Hubert's class is basically the power rule with an extra step. And that extra step is take the derivative of what's inside. It's as simple as that. If you look at the book, you'll be lobotomized. You won't know what's going on. So, let's do it. The power rule, you get 1/2 x squared plus 1, 1/2 minus 2/2. And then what's the derivative of x squared plus 1? Say again? 2x. Now I'm going to take my handy dandy highlighter and highlight this because we've taken the derivative of what's inside. So I'll draw an arrow from here to there. Now you just have to clean it up. Oh, don't forget, f prime of x. I don't know what you're doing. You don't tell me what you're doing. You do tell me what you're doing. Okay, so multiply this times this. So f prime of x is equal to 1/2 times 2x over 1. I'm trying to make it easier for you. And then times x squared plus 1 to the what? Negative 1/2 power. Now we're going to clean that up now, but go ahead and finish it. You can use your algebra to finish it. There's no other calculus left. Plus I got to make it smaller so I can keep on going. If it'll let me make it smaller. This is another thing it does. I circle the whole thing and I make it smaller, and it only lets certain parts get smaller. Now this one, this work on now, see, doesn't work. I'll forget it. Okay, so what happens here? Take our red marker. What happens here? The 2's cancel, and you're left with x over 1. Now, I'm going to write it out because you've got to clean it up. So I'm going to write everything in a way that you can understand it. X over 1 times x squared plus 1 to the negative 1/2 power over 1. And now what am I going to do? I'm going to flip this one. Because if I went from this step to this next step right here, half of you would be lost. So that's x over x squared plus 1 to the 1/2 power, or x over the square root of x squared plus 1, or x times the square root of x squared plus 1 over x squared plus 1. And that's the three answers. Look in the book and see which one they did. Yes, sir.
You can only use the chain rule if it's a square root or like to that.
Well, most of the time when you see x squared plus 1 to the third power, or you just, because you don't want to go, you don't want, let's say f of x is equal to x plus 1 to the third power. All right? Your options are f of x is equal to x plus 1 to the second power times x plus 1. And f of x, another option, is to do x plus 1 times x plus 1 times x plus 1. Now, either one of those, what are you going to have to use? You're going to have to use your FOIL method, well, the distributive law here, shortcut number 1 here, and then distribute this, so which is a lot of what? A lot of work. Okay? With this one, it's real simple because you just use your FOIL method because it's to the what? Okay? When you get above 2, you're talking about a lot of what?
Steps.
A lot of work. Okay? So you don't want to do these by multiplication. You just want to do 3 times x plus 1 to the second power times what? 1. And then that's 3 x plus 1 to the second power. And that is the derivative of that. Okay? What was the answer on in the book? Which one did they do? Okay. What?
Square root on the bottom.
Right here?
Yeah.
Okay, so this is the one they did. Which I'll take all three of these. Alright, let's do nerd. Now these can get kind of, when we move to the trigonometric functions, the sine of 2x is not going to be the derivative sine, it's cosine. Cosine of 2x is 2 cosine of 2x. Why? Because you have to take the derivative of what's inside. What's inside of the sine of 2x? 2x. And what's the derivative of 2x? 2. That's why a lot of people get confused when you take the sine of x. When you take the derivative of the sine of x, it's cosine of x. You take the derivative of the sine of 2x, you get 2 cosine of x, and half the class goes, why? Because of the chain rule. That's why. That's why it's very important that you learn the chain rule backwards and what? Forwards. Yes, very much so. It's all about preparation. And if you don't prepare yourself for Calc 1, you're going to fail. So, I'm trying to do everything I can. There's chain rule. Knock yourself out. We'll blow it up for you so you can write it down if you want to. Let's make sure everybody can see it.
Actually, that's not nearly as bad as some of them.
Huh?
That's not nearly as bad as the others, though.
I'm sorry, it's not nearly as bad as what?
As the others were.
No, it's not. But when you look at it, especially when they throw in Leibniz or whatever, I just say, just take the derivative of what's inside. Oh, you got some teachers, they break it up into several steps. I'm serious. And it just doesn't do you any good. Oh, I blew it up. Hold on. There we go. All right. Let's do another problem so you can feel good about yourself. All right. I already did that one. I thought we did x squared plus 1. Yeah. Okay. I guess they're doing it again. Okay, they're already bringing in the We haven't done derivatives of trig, have we? We need to. Where's the trig functions? Oh, we skipped it. Oh well. Well, they're not that big a deal. Let me show you them right quick. Because they're nothing but memory. If you've ever had trigonometric functions, it's all memory. There really is no math involved. I'm trying, people. I'm trying. I'm trying to find. There they are. The derivative of the sine is the cosine. I'm trying to find it. There it is. So you need to write, just put derivatives, and then put sine is cosine. All right, so the derivative of the sine is the cosine. Write that out. The derivative of the sine is the cosine. Derivative of the cosine is the negative sine.
Wait, what was the last one you just said? Derivative.
Right here. Derivative of the cosine is the negative sine. That's the one that's going to mess you up the most. Because when you get to the antiderivative, it's the opposite. So you got to really put that one to memory. In fact, that's one right there that you need to remember, and you need to remember with a trick or something. I don't know how, but it will get you, when we get to the antiderivatives, you'll start getting confused. So you need to make sure you know that one. Derivative of cosine is the negative sine. And the derivative of the tangent is what? Secant squared. Here's the actual, that's the list I was looking for right there. Thank you very much. That's what you need to remember out of 3.3 right there. So write those down. The only homework problems you're going to see is if I give you f of x is equal to 3 cosine of x. What's the derivative of 3 cosine of x? The derivative of 3 cosine of x is negative 3 what? Sine of x. That's all there is to it. It's not rocket science. What's the derivative of 4 times the tangent of x? 4 secant squared of x. Why does the 4 come out? Because it's a what? Constant. Thank you. One person that interacts with me. Okay? Now, what was you talking about a while ago, Hubert? I was talking about cosine of 2x. Is 2 cosine of x and cosine of 2x the same? No. And that's why you have different. I'm not worried about you taking the derivative of these guys because unless you can't read, those are easy. These are easy. Okay? Now, let's go through and work the problem I was going to work. Now that you got these down. Everybody got these down? They're on page 193. So make sure you got all 6 of them down. Derivative of the sine is the cosine. Derivative of the cosine is the negative sine. Derivative of the tangent is secant squared. Derivative of the cosecant or cotangent is negative cosecant squared. See, there's a little bit of association right there. Cosecant and secant. And then the secant and the cosecant. That's one of those things you might want to take out and put on the index card. Now, I haven't told you to do that with the first rules that we went over because the first rules you need to put to memory. You need to put this to memory, but this is more literary than the first rules. This is more dang old English. You got to look at it and read it. Does that make sense? Dang old literal. All right, let me get back to the chain rule. All right, I'm just going to put It goes along the lines of this one right here.
You're like zooming
Thank you. It's along the lines of page 200. I'm not going to do that one yet. We're right here. But I'm going to do one like it. And then we'll move to that one. So, f of x is equal to 4 sine of 2x. Alright, this is the one that'll get you, or one like it. First of all, what do you do with that constant? Pull it out. So, and this is good when you do the antiderivatives. Get in that habit. Take that 4, dang old, pull it out here. And now you've got sine of 2x. Alright? Now, this guy is just like this guy. Okay? It's just like it. Because you cannot just say, oh, the sine of 2x, that'd be the cosine of 2x. You can't do that. You've got to use the chain rule. You take the derivative of the sine of 2x, which is what? The cosine of 2x. But you also have to do the derivative of what's inside. And that's what gets students in this section. So, 4 f prime of x is equal to the derivative of the sine of 2x is the cosine of 2x times the derivative of what's inside. So I'm going to take my handy dandy highlighter just so you can put it in your notes and you can remember it on the video. This right here, did I not hit that highlighter? I thought I did, but evidently you got to bang on it. And the derivative of what's inside is what? So 4 f prime of x is equal to cosine of 2x times what? 2. And now what is 2 times 4? F prime of x is equal to 8 cosine of 2x. Now you see why people get these wrong?
I thought you meant that you would just do like cosine of 2. Like you didn't have to like times it.
Mm-hmm.
So,
How many of you have had Calc 1 before? Come on. Okay. Did you ever have a problem doing the sine of 2x and wanting to know where the 2 came from? Or did you just know it? Okay, well forget it. I haven't done anything then. Okay. Well, in a lot of cases, this is where students get confused because they don't apply the chain rule. And right here is where you have to apply it. So, the problem that they have in the book, what does it say? Somebody tell me what it says. Okay, in the book, the example that we just did, what does it say? What? F of x is equal to what? Sine of x squared or something like that? What does that say right there?
Sine x squared.
Thank you. I know. Sine of x squared. Yeah, sine of x squared. Y'all just don't want to interact with me. That's all there is to it.
it's 10 to
Be quiet. Thank you, Miss Angie. All right. So, do we have a constant out front? Yeah. What is it? A 1. So, you don't have to worry about that because it's multiplicative identity. But if it was a 2, you'd bring it out. So, f prime of x is equal to 1. What is the derivative of the sine? Cosine of x squared. That's the derivative of the sine of x squared And now, take the derivative of what's inside. And the derivative of what's inside is, and 2x times 1 is, so f prime of x is equal to 2x times cosine of x squared. What did they get? The chain rule is real simple. You take the derivative, like the power rule, and then you take the derivative of what's inside. Real simple. Homework today that I put up will be the what did I just do? Chain rule. Will be the chain rule. I'm trying to think, and when I think, it shuts down a couple of brain cells. So, I know men tend to do that. Women can do it, but men cannot. All right, I'll take the roll, and then we'll talk, because I want to say a couple of words about